Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. I think you're really going to enjoy today's show. Our guest this week is Dominique Simmons, applied research scientist at AI tools vendor Dimensional Mechanics. Dominique brings a really interesting background in cognitive psychology and psycholinguistics to her work in research in AI and, well, to this podcast. In our conversation, we cover the implications of cognitive psychology for neural networks and AI systems, and in particular, how an understanding of human cognition impacts the development of AI models for applications such as media processing. We also discuss her research into multimodal training of AI models and how our understanding of the human brain has influenced this work. In addition, we explore the debate around the biological plausibility of machine learning and AI models. Really, this was a great discussion. Before we jump in, though, I've got a question for you. How would you like one of our beautiful This Week in Machine Learning and AI laptop stickers? I know you want one. We've already sent stickers all around the world, and we'd love to send you one as well. All you need to do is pull up the show notes page, which in this case will be at twimlai.com/talk/23, and drop us a note with your favorite quote from the show. You can also post the quote via Twitter, just mention at TWiMLAI, or on our Facebook page. Links to all of these will be available in the show notes. I can't believe it's mid-May already. Next week, I'll be hosting my Future of Data Summit in Las Vegas as part of the Interop ITX conference. I've got a ton of great speakers lined up for the event, including folks from Intel, Microsoft, GE, Capital One, Level 3 Communications, and Walmart, as well as leading industry analysts and startup executives. Topics will span IoT and edge computing, data management, and of course, machine learning and AI, blockchain, and much more. If you're planning to attend Interop, I hope you join us at the summit. And if you've been meaning to attend the summit, but held out until the very last minute, it is not too late to register. In fact, you can do so using my 20% off discount code by visiting twimlai.com/interop. Of course, if you have any questions about the summit, please feel free to reach out to me via the contact page. And now, on to the show. All right. Hey, everyone. I am excited to have Dominique Simmons on the line. Dominique is an applied research scientist with Dimensional Mechanics. How are you, Dominique?
I'm doing great. Thank you. How about yourself?
Doing very well. Very well. I wanted to start this conversation by talking a little bit about your background. You have a master's degree in cognitive psychology and psycholinguistics, and you have ended up doing work in artificial intelligence. Tell us a little bit about your background and kind of your path to working in AI.
So I'll start from the very beginning. As a child, I was always fascinated by the brain.
Okay.
I grew up as an only child, and I found myself journaling. When I wasn't with my other friends, I'd journal and make observations about, what people are doing, just what was going on in my environment. And what I was fascinated by what made them do the things that they did. And that carried on throughout school. And eventually in college, I had a great mentor who brought neuroscience into our curriculum.
Okay.
And I started, tabling for Brain Awareness Week. I started, learning about the brain and the circuits and just how these processes come about. And so again, that carried me through. I knew that I wanted to do that in graduate school. And after becoming a lab manager at University of Illinois Urbana-Champaign, being a post-bac intern at UMass Amherst. I got a lot of exposure to different types of psychology, anything from, infant psychology, cognitive psychology, psycholinguistics, music cognition, you name it. I was just very fascinated with all these aspects, and you could see these parallels coming together as well. So in graduate school, I studied specifically multisensory perception, which is the influence of one sense over another.
Okay.
And how senses interact. So I come from a school of thought where the brain is agnostic, if you will, to input. And once the input, is processed, then, it becomes sound, or it becomes hearing, or, any one of these senses. But the actual input is just information. The brain likes getting information, and learning and processing. And then at the later stages, that's when it becomes what we know as sensory input.
Okay.
So with that gave me a unique background. So I will say that in graduate school, I got a little bit tired of the theories. Of course, it's it's critical. It's a critical foundation for a lot of work. But I started to get to itch for applications of these ideas.
Right.
This idea of integrating senses. How can we make this into a device? How can it help? Non-hearing populations, or populations that have sensory deficits. And so I worked on a project, a brain training project on hearing veterans with hearing loss. And essentially it was a program like an auditory video game,
okay,
where they had to learn complex sounds in order to navigate through the game. When the sound goes up, they had to jump. If the sound goes down, they had to, duck under something.
Oh, interesting.
And so that was my first taste of the applied aspect, of things, of the applied world.
And the goal of that was assessment, or trying to rebuild new neural pathways to improve their hearing, or something else?
So it was a little bit of both, but really the latter.
Okay.
Really trying to re-strengthen those connections, those auditory connections,
okay,
through training them with complex sounds. And so we build the complex sounds in MATLAB and other tools. And at that point, we were doing some initial testing, but it's gotten pretty far. It's gotten to the point where it's an app.
Oh, wow.
Yeah. So that was part of my graduate work. And then I ended up, so it's funny how I got into AI. It's a bit of a jump. So still on that applied path, I ended up here at Dimensional Mechanics as a user experience researcher in VR. That was the initial space that we were in.
Okay.
Creating VR content and optimizing it.
Oh, interesting.
Yeah. And so that's where I was trying to work on things like immersion, enriching the user experience of someone in a VR environment. What are the perceptual aspects that come into it, and how to build a better immersive environment for users.
Okay.
And also, avoiding things like uncanny valley and nausea and all the not so good stuff that goes with VR. But eventually,
uncanny valley is what?
Oh yes, uncanny valley.
Phrase, but I forget what the phenomena is.
Yeah, so it's when you see a character that is human-like, but not quite there.
Okay.
And usually you can tell in the eyes, that's usually a giveaway. And you start to get this un, uh, uneasy feeling because, you see the human-like quality that could be there, but it's not quite human enough.
Okay.
And that's a big issue with characters in VR and in virtual environments. So, but eventually we pivoted into the AI space. And so I've been using my background to help build in the cognitive components into our system, things like decision making and perception, and memory as well.
Just out of curiosity, what drove the pivot from VR to AI?
It was, business decision, but I believe that we saw a bigger opportunity, if you will, in AI, especially a general AI platform that we're working on. VR that is vast as well, and there are a lot of areas that you can go into that people don't necessarily recognize. It's way more than the entertainment space,
Right.
but AI it affects almost every single field there is, almost every single area of business. I was on a panel a few months ago, and someone asked, is there any area that you can think of that hasn't been touched by AI? And we tried to come up with one example, but if it's not already, it is going to be affected.
Right.
Yeah.
Huh. And so just for context, and I really want to dig into your, how your background ties into your current work, but for context, you said that at Dimensional Mechanics, you're working on a platform for, did you say a general platform for AI or a platform for general AI? I thought I saw the latter on the website or something or someplace.
Yeah, so it's a general AI platform, essentially a set of development tools for companies so that they can reduce their costs in engineering costs in AI and machine learning. AI is very expensive to produce, and you need quite a bit of manpower, and especially you have to have essentially experts currently. But we are trying to do away with that so that someone who is interested in AI, or a company that maybe doesn't necessarily have AI and ML experts, they can still build models to solve their problems.
Okay. Got it. I thought I read that you guys were going after the AGI problem, artificial general intelligence. But it sounds more narrowly constrained than that.
A little bit, yeah. I mean, we're we're definitely adding to that conversation, and adding to those efforts. We want to build general AI, but it actually, should mention that we are currently in the media space. So, you have to narrow it down somewhat. So we're currently working with companies to build AI models for images, video, and text.
Okay. And I imagine that the media applications lend themselves particularly well to your background and a cognitive approach to, there are clear cognitive elements to AI with regards to media. Can you talk a little bit about how those intersect?
Right. So with, let's say, images and video, for example, I come from it. Actually, as a matter of fact, I'm working on a computer vision project with a local university, and we try to find parallels between, how humans ingest or process, I guess, perceive media. That's the best way to put it, and how a system would do the same thing. And it's, you know, obviously there are going to be vast differences between how a machine does it and how a human does it. And we're not trying to make a one-to-one mapping, but there's a lot to be said. There's a lot of information, and there's a lot of inspiration in how a human perceives media, and that we can apply to how a machine perceives media. So, for example, and you know, in computer vision, you can think of it as like a multidisciplinary field, because you're drawing from vision science, you're drawing from computer science, psychology, you know, cognitive science. And so, you know, and part of that is looking at, you know, exactly. So part of the way that researchers create ground truth for computer vision experiments is they look at human ratings. They'll have, you know, humans view a set of videos, do eye tracking and whatnot, and then try to apply that, you know, that eye gaze data to the system at hand, so that can be built in. So, you know, in by using those human ratings, you can build smarter systems.
Just to make sure I'm understanding all of what you're saying. So we can envision a system where a labeling system where you've got some humans that are trying to label a set of images, and you're saying that in addition to just the label that they're, you know, that they may type in to, you know, or a set of labels that they may type in, you're also doing something like, you know, eye tracking with a camera or something like that to see where they're looking on the images, and that helps you to refine the training process.
Right. There's a lot of rich information. There can be from eye tracking studies in, you know, how humans, what does the eye gaze data look like? You know, one of my focuses is no pun intended, but attention, user attention.
Okay.
And that when we take in an environment, when we're looking around, there's tons and tons of stimuli. There's no way that we can process it all at once. And so with humans, the whole scene is not relevant at the same time.
Right.
It's going to be relevant in basically spotlights. So you can apply that with a system as well. If you may want to enhance certain parts of images or video, but you may want to do it in a fashion where it's focusing on the most relevant information in that scene.
And so back to your grad school research on multimodal and kind of this model of the brain where you know you have just a bunch of inputs and you're processing them, you know, kind of as equals. Are there other examples of inputs or other examples of the multiple modes that you're incorporating into your work today?
Not particularly currently, but I would like to see, and this is something that I'd like to implement later, and it's the, I guess, intersection or combination of audio and visual.
Okay.
I have seen some early work in this, but, you know, if let's say you're watching a video and there's likely going to be audio as well, and where you're focusing your attention is going to be not only influenced by the visuals, but also and also by the audio, but what's critical is the combination of the, you know, spatiotemporal information. That's something that's going to heavily influence where your attention is guided in a scene.
Mm-hmm.
And so I think there needs to be a lot more research in that space. Previously there's been a lot of studies on this, but there's been a lot of focus on the visual, obviously, right. And there's been some focus on the audio, but really where you're going to find fascinating insights is the combination, what's going on spatially, what's going on temporally, and that intersection.
And practically speaking, how might you expect that to impact an AI project?
So let's say you build a model to detect the tone of a commercial.
Okay.
Well, that's going to use both video, the visuals in throughout the commercial, and then also, advertisers put a lot of focus on the auditory aspect as well. The mood of the mood of the music,
right.
Going with what's going on in the scene. So with an AI system, if you're able to train it on the video and then train it on the audio, and then I'm thinking of like a kind of a thought experiment right now.
Yeah.
So you can see if it can recognize the tone of the video just solely through the visual, and then see how well it does with just the audio. But I bet you that when you combine both of them, you have both types of information that will allow it to best categorize the tone of the video.
Got it. I mean, it sounds like the basic idea is just try to use all the information that you have to make more accurate models. And often it turns out that the information that you have comes in, multiple modes. Some of it is audio, some of it is video, and there may be others as well.
Right. Exactly. If we, the more information that we have available, the more information we can train our systems with. And that's how we as humans learn as well. For example, in the education realm, you have a video of a lecture, you have an audio of a lecture, but if you are not only, you're using both, and, it's the best is if you're actually in the classroom and immersed and you have both sensory streams coming in, the
right.
visuals and the auditory, you're going to have a better chance of, remembering the content and being able to build off of that as well.
Right. Now, a lot of your work calls into question the whole notion of, biological plausibility for neural nets and the extent to which we should be trying to model neural nets and AI systems after human systems. And in fact, you wrote about this in a blog post last year. What are your thoughts on, this whole question?
It's debatable, definitely. And depending on, what your background is, I've seen some hardcore computer scientists where they're like, you don't need this plausibility. But since my background is very brain heavy, I definitely want to include that in the conversation. Say, hey, okay, well, to what extent do we need to model these systems after the human brain? It does not need to be a one-to-one mapping. I do believe that, because with the brain, the human brain, and a computer, the lower level bits are very different. There's some similarity there with neurons firing, and the binary bits for computers. But it wouldn't be in our best interest. There's so many other things that we need to tackle right now. It wouldn't be in our best interest to try to make a one-to-one mapping. But these systems, in my opinion, should be biologically inspired. So we can take concepts like modularity, or integrated systems, localization. We can take all of these aspects from neuroscience and cognitive science and apply them to building these models. And I personally try to keep that in mind when I'm building various AI models.
Now, I think of modularity and locality as computer science-y things, as technical things. Can you talk about how those concepts express themselves biologically and how they've influenced the types of models you build?
Sure. So with modularity, it's the idea that the brain processes, there are different areas for different processes. Like there's an area for language, there's an area for motor, there's an area for other types of processes and systems.
Okay.
So, and they're believed to be all encompassing, if you will, or self-contained.
Right.
I'm not particularly from that school of thought. I think there's relevance in that school of thought, but there's also a ton of interconnectivity. So, and that's really, it's literally all connected. And, even if there's some localization, particular area for language, that's going to influence the visual processes. That's going to influence, the auditory processing. So it's, in my opinion, it's really all about interconnectivity.
Okay.
But as far as building AI models, so this is kind of going back to the thought experiment that I brought up. But you can think of it as, when you're training these models, you can think about what kind of I guess you can think of it in terms of sensory input and separate streams or combined streams. So you can, feed in audio, you can feed in video, and then you can feed in the combination of that.
Okay.
And you can think of that as the interconnectivity equivalent, if you will.
So this reminds me of some conversations I've had recently about folks working on deep neural nets, and this question comes up when they're trying to develop these complex deep neural networks, whether they're ultimately developing this single model that takes in all the input and produces all of the outputs, and it's kind of monolithic, or whether they develop, what looks more like an ensemble in a sense of, or a hierarchical neural network model where they're taking in, inputs and training the model to be able to determine, some kind of higher level feature. And then they have, many of these in parallel that they feed into kind of a higher level neural network to, make the ultimate decision. And this may happen in several layers. It sounds like what you're saying is that is ultimately more, that's closer to what the brain is doing than we think of the brain, I guess, as lay people as a kind of this monolithic thing, but you're saying that in many ways it's kind of hierarchical. Is that accurate?
Yeah, I mean, and you can take a particular system, the visual system, for example. So, you get the early visual sensory input, it's really globs and shapes and shadows. And then as the input gets further up the stream to V3 and V4, then you start to actually make out a particular image, a scene of a park or a beach or whatever it is. So yeah, it goes from sort of like a lower level abstract to the more, and yeah, I mean, I agree with the idea that, we have these lower level processes that are done first, and then as they are being carried out and further processed, then you get things that are more fine-tuned, fine-grained, if you will.
Mm-hmm.
You can also apply that to the motor system as well. At first, when your motor system is still developing, you're going to have clunky, non-coordinated movements. But then, as you go further along and you can fine tune them and fine train them, then you're able to write, you're able to type, you're able to do more fine-tuned movements.
Are there a set of principles? Do you think that anyone working in this field should be thinking about as they're approaching developing AI systems with regard to this whole issue of biological reference or plausibility?
I would say think in terms of being interdisciplinary. There are a lot of areas that come together in AI, and I think in order to develop successfully, you need to borrow from each of those. Like I said, computer science, cognitive science, psychology, all of these different areas are going to get you are going to help you build a better foundation, as opposed to just focusing on the computer science theories or the cognitive science theories. You really need a combination of all of them.
Are there a set of canonical references that folks should take a look at to dig into this area more?
It wouldn't hurt to read up on the history of AI. I think it's a little known fact for some that it's actually been around since the 50s. Mm-hmm. A man named Marvin Minsky was, he's considered to be the father of AI. I would read up on him, his work. I'd read up on Alan Turing. Mm-hmm. He laid some of the foundational, thinking in AI. I'd start there.
Yeah. Awesome. So maybe let's try to dig into, some more concrete things. Are there specific applications of what you guys are doing at Dimensional Mechanics that we can maybe talk about, or what, ways that you're helping customers develop AI applications with your platform?
Yeah, so we have a demo on our site, actually. I wish I could go into a lot more detail, but for now, I'll just mention the demo on the site, and that's an image ranking demo where you can upload a photo and it will give it a score.
Okay.
And relative to the existing photos on there, you can see them, you can scroll through them. There's a top 10 list.
Okay. And it's scoring it from what perspective?
So it's trying to give it the best ranking. So it's using a lot of different metrics. Can't really go into the particulars, but
is it trying to label the image or trying to rate its aesthetic quality, or
it's trying to rate its aesthetic quality.
Okay, got it. So it's kind of I don't know if anybody remembers the Hot or Not app. It's kind of the Hot or Not app for images.
Right. We that's brought up and that's been brought up in our discussions.
Okay.
But yeah, like I said, it's rating the more aesthetic qualities of an image.
Okay. And in what ways has the your work around the cognitive psychology influenced how a system like that works?
So part of this is going to go back to, how a person perceives an image. And I'll just give, very general examples. So, when we see an image, we're taking in a lot of aspects. The shadows involved, the lighting, the angle of the object, the sort of the busyness or the contrast involved. So we're assessing all of those things when we're an image. And you could say that the system is doing something similar.
Okay.
This is kind of getting me into another space. So one thing, it's interesting. So have you heard of the black box problem?
Generally, yes.
Generally,
I've
okay.
heard of a black box problem. I don't know if it's the same one that you're. When I think of the black box problem, I think of that from an AI explainability perspective.
Right. And that's what I was going to get into.
Okay.
So and there's a parallel with humans as well. So, we as researchers, we present a set of stimuli, and then, a person responds to those given stimuli. But what's exactly is going on in between is, it's debatable sometimes,
right?
More times than not. And with AI, that's one of the things that we're trying to work on as well. Not necessarily dimensional mechanics, but as a field. Yes. Trying to demystify what's going on in between. And I think that taking a good hard look at the training sets that and manipulating those in a way where you're feeding in sections at a time, and that this section has particular features, this one doesn't. That can possibly get at that question, but it's going to take a lot more work. Mm-hmm. And I think once we do that, we'll be able to, AI models will be that much more valuable because we'll be able to tweak as necessary.
Right. So going back to this demo application, presumably you developed some AI model to rank these images, and you've trained it on lots of input data. Did the multimodal training come into play in this case?
Not in the current iteration, but that is something we would definitely want to explore on how to make it smarter, if you will.
Right.
Yeah.
Yeah, I can imagine. If someone is rating images on a numeric scale, but you also had a camera looking at them, observing them, then there's a ton of additional information, like the creases in their eyes when they smile, the smile, the eyes, that could perhaps lend some additional insight as to whether this is a visually appealing image.
Right. There's so many factors that come into play. Like I said, whether you have the right lighting, whether the expression on someone's face, what that's conveying. There's so many things. So it would be great to further explore it. We've built it on a particular set of features, but we would definitely like to expand that in the future.
Mm-hmm. Are there any other kind of applications or use cases that might be interesting to explore?
Oh, there are tons. It's really about having time to explore them.
Yeah.
Yeah, there's
it would
so
be great
many.
to get a sense for, I think you've given us a sense thus far that having a cognitive psychology background can really lend insight into, ways to think about, your modeling and your training. And it would be great to, then talk through some examples of, how that's kind of played out in kind of a customer scenario or just a practical scenario so that folks can kind of see the line kind of go from beginning to end, if that makes sense. Okay.
And I've touched on this a little bit earlier, but we're looking at what we're looking at user interest and engagement.
Mm-hmm.
Essentially, when you see a scene, what's relevant to you, what catches your attention.
Right.
And once various factors of that can be identified, and by the way, we're looking at both lower level features, things like line orientation and color, very low level features that would grab your attention automatically, if you will. And then also higher level things like emotion, things that more, I guess there's a term, top down attention.
Okay.
Which is intentional based. You're looking at something intentionally.
Okay.
Or goal oriented. So the possible applications of that research. So I've talked about the advertising space.
Right.
So for example, if advertisers can take this research and realize, okay, at the 30-second mark, this is where this particular location in the scene, this is where people are going to be most engaged, most, they feel like there's something most relevant in that particular area.
Mm-hmm.
Well, that could be a great placement for product ad,
mm-hmm.
Or product logo. You can also get a sense of how long you're going to be able to sustain someone's how much time someone's attention is going to be sustained.
Right.
In a world where we're on our phones all the time, that gap is shrinking.
Right.
So, with advertisers, it's that much more critical to find what's relevant and get in there before the user's attention is lost.
Okay. So then through this research, you're developing models that can look at, is it only static images or is it video as well in this project?
It's video as well.
Okay.
Actually, in this particular project, it's video.
Oh, okay. So you're basically training models to model human attention and interest on these videos, and then you can use that to help advertisers assess their work, for example. So as opposed to convening a panel or focus group to try to get a sense for whether an advertisement is effective, which is probably expensive and time consuming and maybe not even all that accurate, you can use these models to screen the advertisements screen the advertisements for effectiveness. Is that the general idea?
Right. And going off the accuracy point, so, a lot of times in focus groups and whatnot, there's a verbal or written response, but a lot of times what we say is not necessarily reflecting what's going on internally.
Right, right.
And we try to get at that as well. We currently use tools like eye tracking and biometric sensors, so to get at the physiological responses to the input, to the video input.
Okay. And I forget if we covered this, but what do you call that phenomenon? Like, I know a related idea is, I guess you would call it attribution error, or issues around attribution, meaning if I look at an image, I can tell you I like it, but I can't tell you necessarily why I like it. Is there specific terminology for the other side of this, which is, I might say I like it, but I might not really like it, or vice versa?
Right. Well, there are a lot of things that come into play, especially in an experimental setting. So there's experimenter bias. If there might be some influence of the experimenter, you have to be careful in the way that it's asked. If you are going to ask, sometimes the question in itself can be loaded and bias the response.
Uh-huh.
This is getting into another area, but with eyewitness experiments, the way that you pose a question can definitely influence how the person will respond. You can, let's say there is an accident, and you throw in an object in the question, like at the stop sign, blah blah blah. Well, the fact that you mentioned the stop sign, even if there wasn't one there, the person may still agree and say, yeah, okay, I remember the stop sign. It's like, no, there wasn't even a stop sign there at that
Mm.
particular scene. So, so there's experimenter bias. So you mentioned attribution, but you also want to be seen in a particular way as well when you respond.
Right.
So you have to keep that in mind. And we may not even be conscious of that. We want to produce positive responses.
Mm-hmm.
So, to get away at all that, I think a great measure is more something physiological that, it doesn't get a chance to reach our thoughts.
Mm. Mm-hmm. Interesting. So beyond just this attribution issue and my ability to articulate, is a whole host of cognitive biases that can distance someone's real perception of an image or video from what they ultimately say in some kind of panel or focus group, and thus being able to develop machine models that can, not just rate the image or model a human reception of an image, but also maybe tell us a little bit, as we kind of get further along with the black box issue, tell us what the issues are. This one may be too dark here or too contrasty there, that kind of thing.
Right. To give, possibly a more objective measure, if you will.
Mm-hmm. It sounded like you were wrapping up this research project. What's on the horizon for you? Are there any particular areas that you're looking forward to exploring further?
Right now, I am working on learning more about the natural language processing space, which I
Okay.
find really fascinating, especially with my psycholinguistics background. So, for those who don't know, natural language processing is the ability for systems to take natural text, anything as short as words, phrases, and to documents, full documents, novels, even, and be able to get insights out of that input data.
Mm-hmm.
Things like, you can get more technical things like frequency counts and whatnot, but you can figure out the sentiment of a particular text. You can figure out all kinds of things
Mm-hmm.
that, it would take a person hundreds and hundreds of hours to do.
Right.
You can just load in all of these documents and, get a score for sentiment. Is it particularly positive or negative, or all kinds of different insights?
And what is piquing your curiosity around NLP and the application of psycholinguistics to that field? Maybe we can start with what is psycholinguistics relative to traditional linguistics or other aspects of linguistics.
Sure. So linguistics is, the study of language, the parts of language, the structures and whatnot. And psycholinguistics, it's bringing in psychology into that. You're looking at things like the way in which people say things. That term is prosody. the inflection in someone's voice to convey certain messages.
Okay.
It's fascinating. You take one sentence, the man went to the park. The man went to the park. The man went to the park. You can say the exact same thing, but put different inflection on it, and it has a completely different meaning.
Okay.
There's, the way in which we produce sentences and the, syntactic structure and how that affects both the producer of the speech and then also the, listener as well. It also gets into, co-articulation and these other mechanics of speech that.
What's co-articulation?
Co-articulation is when it's so it has to do with the flow of words. When we're speaking, all of the words seem discrete, but if you look at an audio form, waveform, you'll notice that the sounds actually overlap. And so that's the co-articulation. Then you also get into the social aspects of speech. So when two people are conversing and there's a phenomenon that occurs called common ground, and that's when you start out using different terms, but over the course of the conversation, you start to use similar terms to each other, if not the same ones.
Oh, interesting.
Because you've built up a rapport. There's so much. There's also this phenomenon where, you're building up that common ground, but then you also take on a similar speaking style to that person. And that can also convey that you like that person. You can also, and that's called convergence.
Okay.
There's also divergence, where maybe you're not a big fan of that person, and you start changing your speaking style, maybe unconsciously, but changing your speaking style nevertheless.
Interesting. So when I think of natural language processing, I tend to think of applications that are, either primarily textual or, translation types of applications. But just your little explanation of psycholinguistics and given some of the background we've talked about, it strikes me that there's a ton of interesting work and exploration to go into. How do I articulate this? Well, maybe to articulate it by example, like when you create a neural network to recognize images, right? When, we know a little bit about how those neural networks structure themselves, and you've got kind of your edge detectors and your, shading detectors and all those things that emerge. I wonder the extent to which the concepts like prosody and other things, if you're training a neural network on speech samples, if there are regions in the neural network that emerge that somehow reflect, prosody, for example, or if that's is that kind of the current frontier of research?
Yeah, that's definitely on the frontier of this research in this particular space, especially audio. Visual inputs have been fairly well studied in the AI space, but audio less much. Part of the issue is the shortage of data in that space. There are quite a few open source video and image data sets, but not so much on the audio side. But going back to your point, yeah, I believe that what you would do is you would set, prosody up as a feature. You'd set, co-articulation or these other, syntax. You'd start to set these up as individual features to train the models.
Meaning that you would have humans identify them somehow and label them, or how would you set up prosody, for example, as a feature?
It's a good question. So initially, it would likely have to be at least partially supervised, and you'd want to use some sort of existing rating, so probably human ratings. And I can imagine, you have a waveform and they, listen to the speech snippet and mark places where goes high or goes low. This is also evident in the physical waveform as well. So I could see that even being done without human ratings. But the system, you feed it various waveforms and you feed it the sounds that go with it. It should be able to learn the parts where the audio goes up, and then the times where the inflection goes down. But the tricky part would be associating that with a particular meaning, and that's where you'd probably need humans to come in. So humans would tag the particular sentence as, the emphasis was on this, or the emphasis was on that. And then once you have those list of different emphasis, you could train the model on that. And so ideally it would know when the inflection goes up, that's where the emphasized meaning is.
I would imagine that traditional linguistics has a lot to offer in terms of, just how to represent all of this stuff. Like, it strikes me that, there's a representational challenge in, if someone were to try to take this approach to, building and training models. But, certainly linguists have been, representing prosody in some kind of way and developing ways to map that to specific meanings. Is that correct?
Yes, that is correct. And so it's definitely worth a look if someone is trying to train on audio models to, take a look at that space. That's why, going back to what I said about being, thinking multidisciplinary, it wouldn't maybe be obvious to go to the psycholinguistics area, but it like we've been saying, it can give you some great insight into how to train an audio model. And it'll give you more than just the surface characteristics of a waveform or the audio. You'll be able to train it on meaningful insights as well. His prosody is not something that you can necessarily, you can see the inflections, but you can't necessarily see the meaning on the physical waveform. You need to add that insight,
right?
In addition,
right? Oh, this is a really, really interesting space. Any other thoughts before we wrap up?
No, I think this is a great space as well. What I particularly appreciate about it is, like I said, the multidisciplinary aspect of it. We're building these very complex systems, and I just mean that as a field,
right?
In addition to my company, but we're building these complex models that in some respect reflect what's going on in a human brain, but we need to keep in mind that the more complex they get, the more information that we're going to need to seek out, and it's going to come from different places.
Yeah, I can definitely see that. I think I've commented here on the podcast, or certainly on Twitter, that if I wasn't so busy trying to figure out this machine learning and AI thing, linguistics would be high on my list of things to figure out. It's a fascinating field, and it's great that you get to combine the two.
Yeah, it is great. And one thing I did want to mention is that ideally, the system would be language agnostic. So, we're really teaching it about human language, whatever it could be French, Spanish, English, whatever it is,
Right.
Which is very helpful. And it can be used in, like you alluded to, translation tools.
Mm-hmm. Yeah, my favorite example of this, in fact, is from a conversation I did with recently with Shubho Sengupta from Baidu Labs, and he talked about how they were able to build a English to Mandarin translator. I believe it was English to Mandarin translator before they even had any, without having any Mandarin speakers, on their staff, just based on, this property that you're describing, the fact that a lot of the application of this is language agnostic.
Exactly, because it's not working on those particular nuances, if you will. It's looking at it with a more agnostic view.
Mm-hmm. Awesome. Well, before we go, what's the best way if folks want to connect with you or get in touch? What's the best way to do that?
You can connect with Dimensional Mechanics on Twitter at DMINC_AI. Mm-hmm. And we're also on Facebook and LinkedIn. You can connect with me personally at ArtSci, ARTSCI, with 2 zeros, at Twitter.
Okay. So at ArtSci00?
Yeah.
Awesome. Well, Dominique, thanks so much for being on the show. It was great chatting with you and looking forward to reconnecting soon.
Thank you, Sam. I really appreciate it. Thanks for having me on.
Absolutely. Take care. Bye.
Bye.
All right, everyone. That's our show for today. Once again, thanks so much for listening and for your continued support. Don't forget to share your favorite quote from this show via the show notes page, Twitter, or our Facebook page. And if you do, we'll be happy to send you one of our laptop stickers. If you're planning to attend the Future of Data Summit next week, please reach out and let me know to look out for you. The notes for this show will be up on twimlai.com/talk/23, where you'll find links to Dominique and the various resources we mentioned in the show. Once again, thanks so much for listening, and catch you next time.